All right, so 17 says reservoir discharges into a 4-inch new cast iron pipe. So I wrote that, find the velocity of the discharge, consider friction, but neglect minor losses. So we are at the discharge point here. So velocity 1 goes to 0, velocity 2 we will have here. There's no pressure because we're at the discharge. But we don't have a friction factor, not given to us. We do have new cast iron, so that gives us the roughness factor. I'll also collect that. New cast iron new 0.00085. 0.00085. So again, we got to develop that formula that's on the bottom of page 62. So the one that I like to write is H1 minus H2 equals, they call it 411 is the name of the equation. And there's brackets, 1 plus the friction factor, LD V 2 squared over 2G. So that's probably the easiest one to use to develop the formula. So then you can then guess the 0.02. So H1 is 515.50. H2 down here at the discharge, 489.20. So I'm just going to develop that number and put it in. 26.3 feet equals 1 plus, it's going to be, my first guess is going to be the 0.02, but I'm just going to leave it as F because it usually takes a couple guesses. Do we have a length of this thing?
175.01.
Because it's again so flat. Yeah, 175.01 feet. Our diameter is tiny. What is that? 4/12. That's 0.25. Yeah. Yep, so that's it. Once you have that, you can start your guesses. .02 is my first guess.
What do we want to times the 64 over?
Sure, you can boil it down to however you want. I boil it all the way out. B2 squared, right? B2 is what we're aiming at. We put this in. We get a velocity out, and then we go to Moody's to check. Right? Yep. So yeah, as far you can take this equation out as far as you want, or you can leave it just like this and start, plug and chug.
Is the L over D, is the D supposed to be the diameter?
Yep.
Yeah.
Shouldn't it be 0.4 over 12?
4 enter 12 divide. Yep. Good catch. I did that math in my head. It's bad math.
That's one of the few things I got right when I tried to do it. So.
Guys plug in the 0.02 yet?
Doing it right now. Not forgetting to add my 1. Did you get a number?
Yeah, 12.135.
Yeah, I need to. Some things are in different spots. I got 12.08, so we're pretty good. That's gonna give me a Reynolds number.
Reynolds number is 402,666.
Yeah, so how are we gonna write that for the Moody's?
It should be 4.02 times 10 to the
Yep.
5.
Yep. 4.02,
666.
yep, 5.
Put that in the-
And then my relative roughness factor is the 0.00085 divided by the 0.33.
0.00255.
Three, 2 zeros, 0.002. That's what I'm getting. Yeah. The 5 is here. Broken a 4 here, comes up to 0.0026, close to 3. So I get 0.026.
Yeah, on here it says 0.0255. So
There we go. We'll use that calculator though. I like that.
getting good numbers so far.
0.0255. Let's plug that back in and come up with our real velocity, assuming those match up.
All these numbers, I ended up checking on the answer of the backup book and what I got. We're on the right. Yep, 10.84.
I screwed up. Seven, 5. So that divides through 26. And then square root 10.8. What'd you get? Yeah, I just got 10.8 flat because it's really, I get 10.799.
The book gave us 10.67 feet per second.
It's not bad. That could be a Moody's thing because they're probably not using the table. So they would not use this as a friction factor. They'd probably use what I came up with, like 0.026.
Yeah.
So as long as we're close. Is that what I wanted? Was the,
And then Q, we need to find Q.
oh, yeah, we need to run the formula now that we have the velocity. Yeah. Because we have a friction factor in here too. No, that's what we need. Yeah.
The number I got?
Yeah.
You just do 0.087 for the area times 10.8. I got 0.95.
For the velocity.
Let's see if that's.
Yeah. I mean, the flow rate. Yeah. So Q is going to be V times A, which is going to be 10.8 feet per second. And the area is going to be our pi 0.33 pi d squared over 4 equals. Ooh, this is different.
You square when you do the 4.
Pi d squared over 4? Yep. Now it's either pi r squared or pi d squared over 4. I can't find the square button on my fancy new calculator though, so that's a problem. Where did they hide it? X squared, that's right there. 10.8. There's a few things are in different spots. I don't see pi either. Oh, there's pi. Times 0.33 squared. 4 divide. What do you get? Yeah, I don't. So I'm having a hard time with this.
What numbers do you get?
I got a very small number, but I'm doing it again. 10.8. Oh, that's what it's doing different. It's not giving me the number. Where is number? Oh, there it is. I get 0.924, 0.92. Oops.
The book got 0.929.
Yeah, I got 0.923, so we're a little off, but that's going to be Moody's diagram. All right, we are nearly out of time, so let's talk about the exam real quick. This would be like a crazy hard problem, right? You may get one of these. There's only 5 problems, so they're going to range from super easy to something like this, where you have to work through it. Okay. So have these homework, you can keep your homework if you want. So you have that available to you on the exam. So you can have the book. I'll have Moody's diagram available to us. So remember, it's going to go all the way back to chapter 1. So kind of review those chapters. You're going to get some simple problems. Don't make them more difficult because they might look like a difficult problem and they might just say, you know, like this one, I could give you this 5 times, right? But on the first problem, I might say, what's the pressure at station 2? So something like that. So don't make it more difficult than it is. Or I could ask you, you know, several questions about the same kind of problem. I won't do that, but you might see the same one a couple times type of thing.
I have a question real quick.
Yeah.
You know how we were figuring out pressure earlier and it was just depth times the specific weight of water?
Yep.
So since we know the, how far down it is at point A.
Yep.
that one we were trying to find earlier.
Yep.
Could you still do that?
You could do that, but it wouldn't consider friction.
Oh, yeah.
Yeah, and the flow rate. So, but it wouldn't be a bad idea to just do that rough number because it does give you an idea of what the pressure is down there, right? And then when you calculate the pressure, like the one where we did the pressure, right? We got 762 as our pressure. It would be interesting just to use the depth and calculate that pressure, just to compare it.
233.94 is A. What was the top?
268.
34 times 62.4, 2,125.34.
2000 compared to,
Yeah, specific weight of water is 62.4, yeah.
yeah,
Okay, well, then,
compared to 762. Yeah, so the number you're calculating is if this is just closed off, right?
yeah.
So we don't have that much pressure. The pressure we have is from the friction in the pipe. And that's it. So anyway, I guess that wasn't a great way to guesstimate. Did give you another number, I guess. But go all the way back. Go back to chapter 1 and kind of review what we did there, right? We really just focused on, not sure we did a lot out of chapter 1. We did a couple things, but really it was just basic mathematics stuff, finding areas and stuff like that. So maybe chapter 2 might be a better starting point for you to review what we did. But that's back to the whole specific weight, specific volume, density, those whole conversations. Make sure you know the differences between all that. And then chapter 3 is where we did buoyancy. You'll probably see a buoyancy problem. You know, it could be a sloped surface. I will not do a curved surface. We didn't work much with curved surfaces, but you could see a sloped surface underwater and asked to be calculating the buoyant, right? The hydrostatic force, the buoyant force. So it's definitely something to look back over. You'll see something to do with that, which was hydrostatic force. And then you'll also see something to do with buoyancy. So a super simple problem, a buoyancy problem, a hydrostatic problem, and then this conservation of energy equation problem. That's what will be on. So those are definitely things to look back over and kind of digest so you know how to attack those. Yeah, we did hydrostatic force and then we did buoyancy. That's the early part of chapter 3. So like 30, 31. Yeah, 29, 30, 31. Vertical surfaces, horizontal surfaces, and then an inclined surface are the 3 that we did. Yeah. All right.
Not
We
the
will-
3-step.
We will do it Monday. Hang on to those homeworks and we'll turn it all back in on Monday after your test. All right.